Well, you can't get into restaurants. Restaurants, they want the restaurants is the last.
It's 2:30 local time. We intend to start on time. Got very busy agenda, so please take your places. Welcome to Vienna. I cannot even convey how happy I am to see you all here, all 10 of you at least. So, welcome to IETF 113 routing working group, and we'll start with meeting. As usual, not well, please make yourself familiar with how your contributions and participation in IETF is treated. IPR disclosure at routing working group will ask you to declare IPR when the individual document progress towards working group document and before working group last call, unless we have received all IPR statements for all authors and contributors, documents won't progress. Let's review our agenda quickly. There are more explanation on the wiki, so I'll be very quick. We'll have Young for QoS, thanks for authors. We are pretty much ready for working group last call, last reviews. APN will update us with all the progress they've made over the last couple of ATFs. We've got a number of research topics, a lot of interesting new work, as well as update on RFC 5798. Thanks, AC, for taking it up. We don't have any RFCs since 112. We've recently adopted point-to-multipoint BFD for VRRP. Working document, the QoS model, as I said, is getting pretty much ready for working last call. Rtgwg standard as well. BGP peak is pending AD review. AD is here to remember. So thanks for Stuart Bryant for reviewing TILFA draft. There's still a couple of reviews that needs to be addressed by the authors. APN BGP has reviewed by a couple of people. We need more reviews here. And authors of the Service 6 egress protection draft have requested working group last call. So we are about to start the process. And please use our wiki to get more information about progress of the drafts, about work that's going on. There's also new work coming in. So we are ready to start. Engine, you are going to start sharing, right? You preloaded already.
Center is Asim. Yeah, you can do the slide sharing yourself. Just click the share preloaded slides.
Okay, so you will be moving the slides for me, right?
I can do it, or you can, if you prefer to do it yourself, it's also okay. You can click the share preloaded slides. Oh, I'll do it for you then.
Okay. All right, I can start, right?
Yes, please.
Okay. So hello everyone, my name is Asim Chaudhary and I am going to cover QoS Yang model. Next slide. Okay. So in the latest version of the draft, we have added a configuration for randomly detect and weighted randomly detect. We have taken care of a lot of Young doctors' comment. We have added a lot of acronyms and definitions. We have improved the language and explanations. And we have added a lot of references as well. And in addition, we were facing some draft warnings. We have taken care of those. And based on those modifications, we have come up with version 7 of the draft and we have published it. Next slide, please. All right, so if we look into randomly detect configuration, it's something which falls under algorithmic drop. and drop algorithm. Drop algorithm is appended to the queue configuration. Now the queue can be configured inline versus a queue can be configured as a template. So under the queue, we have drop algorithm, and under the drop algorithm, we have case statement for randomly detect or weighted randomly detect. Now, if we talk about randomly detect configurations, we have a minimum threshold value and maximum threshold value, and there are corresponding units to it. So the units could be in bytes or in time, like millisecond, or it could be in percentage. And there is a configuration for weight. Now, what is weight? Is a decay factor in calculating the average queue size. Now, weight value is 2's exponent. So, for example, if somebody configure a weight value of 2, then 2 raised to power 2 become 4, and that means the instantaneous value of the queue will account for 25%, and the previous average queue size will account for 75%. And so forth. It reflect or affect the randomly detect algorithm functionality accordingly. Now we also have provided a configuration for max probability value. So it is the probability of dropping a packet at the max threshold value. We have allowed the configuration of units for it too, and the unit could be in percent or per thousand or per million. And it could be also a probability denominator. So for example, if somebody wants to configure, like, I want to drop one packet for every 4,000 packet, then he would configure probability denominator and set the probability value as 4,000. So also, if you look into randomly detect configuration, we have allowed the configuration for ECN enabled, that is explicit congestion notification. And what does that mean is instead of dropping the packet, if you find that the packet needs to be dropped, so if the ECN is enabled and the packet has ECT bit enabled, then instead of dropping the packet, it will be marked, the congestion experience bit will be marked, and it will be sent, the packet will be sent and will not be dropped. Next slide, please. All right, so weighted red is very, very similar to randomly detect, except that we have multiple profile per queue. And that means every single profile represents one color of traffic. So for example, if we have a DSCP value of AF41, we can configure that as a profile, and which will have its own minimum value and maximum value, and corresponding, probability value and weight value. And so, similarly, we can have a DSCP value AF42, AF43, or AF21 as separate profiles under the same queue. Next slide, please. All right, so as next step, we have got, a lot of comments to be taken care of. We have already worked on quite a few so far, and we are working further to address that. Some of them involve improving nomenclature, enhancing descriptions, correcting some of the definitions, formatting one or two sections, and further improving the references. And also we are, working on to improve further explanation into the draft. Also, while working on the draft, we actually had added a lot of if features to the extent that, we have, if feature for a lot of actions, which we thought that some vendor may support and some vendor may not support. But eventually we found that, it is causing too many if features to be there. And frankly speaking, those are not required. So we want to simplify the draft to get rid of some of the if features, which are anyway common features and expected to be implemented. And so we'll be simplifying the draft further by removing some of the features. Also, for the statistics, we had created a separate draft for the stats for the QS model. The reason that time was that it required a lot of discussion for every single counter. And we thought that we'll be taking too much time and we can separate it out. But over a period of last several months, we have quite stabilized the counters. We are not further changing, except the WRAT counter we have added this time. So it's a pretty stable draft and we agree on those counters. And so we want to merge back that particular stats module back into the QS model so that we have a common model for configuration as well as for statistics. Yeah, I would like to address, see some of the comments from the working group on that. Thank you very much. If there are any questions, I'm ready to address that. Any questions?
I see there's comment from Adrian on the chat, so probably we could do it offline. Thanks, really good work, and we are getting there.
Okay, thank you.
AC, you're next.
Okay. Can everybody hear me?
Yep.
I'm AC Linden from Cisco. Aditya Dogra isn't on the call, but he's the team lead for the iOS XE implementation of VRRP version 3. And Steve Nadas was the original, not the original offer of VRRP, but the original offer of the offer of RFC 5798, which took it to V3 and consolidated stuff that was in both the existing RFCs and a draft on VRP for IPv6. Next slide. Now, unless you've been living under a rock, you're aware that a lot of the major vendors, Cisco and others, have adopted a plan to try and replace their documentation, replace all the terminology that is non-inclusive into inclusive. And at the same time, this was happening, a few years back. And then about a year later, the IETF came up with the same, and others. I'm not really keeping up with other standards organizations, but other standards organization did the same. So as from dating back to 80s, the whole terminology of master and slave was very common in networking protocols. Both in the IETF and the IEEE. So what the main motivation was, we looked at VRRP version 3 and RFC 5798, and we could see that just issuing a draft that updated it, it was almost as if every paragraph included the state master. I mean, there definitely wasn't a page that didn't have it. And what we chose was to leave, it wasn't master and slave, it was master and backup in VRRP. Since I was involved with the first one, it was about in 1994 that the first VRRP version 2 became a standard. Ever since then, it's always been master and backup. So we're retaining backup, but we're replacing master with active, which seems to be a very natural choice. It seems like it's consistent with other high availability protocols and things to have an active and a backup. And at the same time, since we're doing a biz, we're fixing all the errata. Actually, there wasn't that many. I fixed them after Aditya did the initial changing of all the terminology. And another thing now, this time, we're hoping to get some good reviews. I remember when 5798 biz came through, I didn't think we got, I reviewed it really well, but I don't know that we got as many reviews as we should have. Now, we might investigate it, taking it to internet standard. I don't know. I'm pretty sure, since this is just really a terminology change, I'm hoping we can just leverage interop testing that's been in the past. We'll start a thread on that. It's not the last one isn't a high priority. It's just that if we can do it as a byproduct of doing this biz, we'll do that as well. Next slide. There's other RFCs. There's also there's RFC 6527, which has the VRRP version 3 MIV. Now, we don't have a firm plan, but Aditya says he's interested in doing this. So I think he'll watch this space once we get this one adopted for this.
AC, would you want to take questions now or then?
Yeah, I'll take them now.
Here.
Keyur Patel, Arcus. Hey, AC, quick question. It's great to see you've replaced the terminology here. Are you planning to do the same with the Yang model for this protocol?
Oh,
does it need?
Are you a plant in the audience? It's
I don't think so.
It's on the next slide, or the slide after the next one.
Okay, super. Thanks.
Okay.
Greg Mirsky.
Be jumping ahead of AC. Just to let you know, I already uploaded their updated BFD and VRRP document aligning with the terminology. And thank you, and I support this work.
Okay. Oh, the draft. Yes, that draft. I didn't mention any drafts in this presentation, only full RFCs, because I just assumed if this gets accepted as a working group document, people will update the draft, the inner working draft between VFD and VRP, and any other drafts that pertain to VRP.
Yeah,
okay,
that would be
slide.
accepted.
This one, once we get this accepted and maybe it goes through a review cycle, this is a very short draft, RFC 7910. I'll contact the offer, Jeffrey, and I'm sure it wouldn't take much to do a biz on this as well. It's an informational draft too. And next slide. Yeah, I'm a co-author of this draft, the Yang model 8347. So I plan once this one settles a little bit, at least gets accepted as a working group document, and maybe I'll start work on this one. We know how to do both for the MIBs and even the Yang models. It's a little painful, but we know how to do it. We can deprecate. I think we can deprecate the old tables and bring in the new tables. Kay, are you going to say something?
Yeah, Keyur Patel, Arcus. Hey, we would support this work, and as soon as you change this, we'll be more than happy to show interoperability with the new RFC as well as the model. Okay.
Yes, that's a good point. Like the MIBs, whereas the code changes are pretty much just cosmetic for the base protocol, the show commands or whatever. The MIBs and the MIB and the Yang model will require deprecation of old tables in the case of VRP and old Yang nodes in the case of the Yang model. We plan to do that. I know I did do some work. It's gonna take more investigation to see what the least intrusive way to do this. The good news is I don't know of any implementations of this draft. I could ask the main offer, who is Shu Fan. I'll ask him if he knows of any.
And Kiyo's showing his finger, so Arcus has an implementation.
Oh, of this as well. Okay. Okay. Yeah, I guess I should, that the second sub bullet is wrong then. And the final slide. I think this is a good place for it. I think VRP, since we don't have the VRP working group. And then we could possibly discuss this terminology, but really I think active is a natural choice. I know in things like this, it kind of gets into be a naming contest, and people will put out a suggestion just for the sake of putting one out. But unless you have a real good reason to choose something other than active, we really don't need any suggestions. And I'm requesting working group adoption.
Chris?
Hey, hi AC. I was just going to make a comment about the Yang. I think you'll be able to run them together, right? So that it won't be, it'll be backward compatible, right? You could have the old names and the new names return the same data.
Yes. As a matter of fact, we did something with that I know you're up on all the toolkits and other things. There's other people at my company who do all that kind of stuff. But I remember we did the same when we did the NDMA model for the Yang routing model. It was on that. It was me, Lou, and help me out.
Well, in any case, we have an example that way, so that's good.
The guy from Prague, who's in the ISP there.
Peter Senek?
No, Peter works for us.
Oh.
Peter's from Slovakia, Bratislava.
I think we need to cut here. We'll figure out for the other guys.
So that was my point, that I think it'd be done
You
backward
meant
compatible.
Lada, right?
That's who I mean. You got it, Yingzhen.
Yeah.
Okay, so we'll talk to our AD with regards to right place. I think routing is the right place to treat all VRP bit drafts, but we need to confirm. And AC, thank you for taking the work. I think it's important to use inclusive language. Alvaro, any comments? Or?
Sure, Alvaro Routing AD. So as long as we're here, why don't we ask if there's interest in the room here and virtually, of course, to take on this work here. I believe it probably, this is the right place, right? There's no point in spinning anything else up. So why don't we ask that, and then we make the decision of whether we do it here or we do it somewhere else.
Okay, so we'll take it to the list, right? Oh, you want to ask it right now?
Yes.
Dear routing working group, do you think routing is the right place to do respins or VRP biz drafts?
Oh no, don't we have a tool? Isn't there a way to raise your hands?
Oh yeah. So on chat, people are agreeing with this, so. Okay.
You have to create a poll, and then we can vote on that.
Okay.
I had a problem with the show of hands tool. Oh, here it is. Now it is.
Alora, seems like we are all in agreement. Thank you, everyone. I see we are taking work here in routing. Let's see. Okay, we are moving to APN updates. Somehow the stuff is not disappearing. Why is that?
Hello, can you hear me? Hello?
Yeah, just a second. Let me try to get it off the screen. Yeah. Please go ahead.
Okay, thank you, Chair. This is Shuping, and Guyan and myself will present the updates of APN. Next, please. I will first go through the history of the APN at IETF. It has been 3 years since we first started the work, and thanks to the feedback we received from the community and the guidance from IESD, we have been progressing. After we proposed the framework in 104, and we held our first SAD meeting, and we gathered our initial interest team, and we started exploring valuable use cases. And in 107, we applied for above for the first time, but it was rejected. And we were suggested that there were similar attempts in the IETF history. We analyzed all the BOFs in IETF, and we further clarified our scope and published the new drafts. And further, we held our second side meeting, and we invited the people who were aware of the history. And also, he gave us the advice on how to progress the APN. And further, we had our second BOF application. It was tentatively approved, but not held finally. And we were suggested to clarify the work in wider community. That's why we presented in the 4 areas in 110. And our third BOF application was withdrawn. And we were suggested that a APN-focused interim meeting will be arranged in Rtgwg. Thanks to this arrangement, we were very well prepared for our BOF. And our fourth BOF was approved and held. Over 200 people attended this BOF, and from all the 7 IETF areas. It showed clear interest and very active discussions. We got a clear summary from the chairs and the guidance from AD. That is that we should publish some solution drafts to show people what are in our mind. And from the BOF, we also got some questions, and we categorized them in total 38 issues. And we systematically work on them and address those issues. And based on that, we clarify the drafts and publish the new drafts and update the old ones. And Guyan is not here, so I will continue. So in summary, you can see that we have, we have presented 6 times in the Rtgwg, and we had 2 SAT meetings and 4 BOF applications and 3 hackathons. And currently we got over 10 active drafts. Guyan, please, you could take over. Thank you.
Sure. Yes. Hi, this is Gyan Mishra, and I'll take over presenting for the next few slides. So we can go on to the next slide. Yes, so after the APN BOF, we had received a lot of feedback from the BOF, and we've gone through and compiled a list of 38 open issues from the BOF, and through that, we had gone through systematically and addressed every one of the issues that came up from the APN BOF. As well, immediately following the BOF, Adrian had put together a nice summary of feedback from the BOF. So just compiling everything, just the entire of what had transpired through the BOF, and then going through it and systematically closing out all outstanding issues. So we made here we do feel we made some really good progress. At least getting a grip on anything that was outstanding and closing everything out. This has all been documented on a GitHub link, and it's in the top right hand corner if anyone's interested in looking at it. That has all the details of the feedback and closure of all the issues. Next slide. So from the feedback and issues, there was 2 key draft updates from the discussions that we had. And one of the key issues that came up through the BOF was related to APN work and APN and related to the limited trust domain and how that works. So and a clarification with that is related to APN is only applied to an edge-to-edge tunnel encapsulation within a limited domain. So from a APN head end, so an ingress node to an egress PE, but it's encapsulated. So as soon as the packet hits the egress PE where the de-encapsulation happens, so from a tunnel source to tunnel destination, at that tunnel destination, the APN header is removed, and then the native packet is exited. So any overlay technology, MPLS or SRv6, where there's an encapsulation, that would be applicable to APN, within that limited domain framework. The other question that came up within the drafts and within the BOF, and we've updated the drafts to reflect, as well as issues that were closed out, was related to an encryption domain and security issues. So with the APN attribute, the attribute is acquired based on existing information in the packet, such as a 5-tuple or Q&Q provider and customer VLAN at the edge of the APN network, and then it's added to the data packet. So the clarification there was related to an encryption domain, and when encryption is present. So with APN, the attribute is acquired based on existing information in the packet header, and then the clarification is the source and destination address of the incoming layer 2 or MPLS encapsulation incoming physical or virtual port information or other fields of the 5-tuple if they're not encrypted. So just other fields, not just the 5-tuple, as there may be fields within the standard 5-tuple may not be readable, may be encrypted. So the clarification related to an encryption domain.
Gunther's question. Lars, go ahead.
Hi, yeah, Lars Eggert. I had actually reaction to the last slide where you talked about the GitHub issues, because it's been a while, but if I remember correctly, I raised an issue that I thought was sort of pretty fundamental and simple, namely, what happens if the application makes a request that the network, for whatever reason, can't satisfy? And the issue was closed, and closed with a resolution to be discussed. And no discussion, as far as I know, ever happened. At this point, I sort of felt a little bit like, my attempt to engage wasn't really being taken seriously, so I stopped. And I'm hoping that wasn't the case for other issues that were closed, but personally, I sort of feel a little bit ambivalent about describing that all issues were addressed when I feel mine at least wasn't. Thank you.
Thank you, Lars. After I've run through this deck, if there's any questions, we'll have a brief period that we can go through any questions, discussions related to any of the open issues that may or may not have been closed, as you had mentioned, Lars. So we want to be open and address any outstanding or anything that may have been prematurely closed. We would like to be openly address any questions. Thank you.
You're breaking out. Please continue. We'll take it over later.
Okay. Oh, we can go to the next slide. Okay. So we would like to ask the routing working group for adoption of the framework related documents. At this point, we feel that there is a lot of interest and support for this work. We think that in general, the routing architecture work, that we have with the framework document is a good starting point. That describes the APN architecture, and I think we feel that we are at a good point with the development of this solution to move forward with adoption. Thank you.
Thank you, Gun. So this is the third update in routing, and in consultation with our AD, we strongly feel that routing is not really the right place for progress in this document. So the options are to create another working group with very clear milestones and dates and how we proceed after, or proceed towards independent submissions. So if Alvaro wants to comment on any of that.
Sure, I guess I'll comment. So just to clarify, the request is for adoption of the framework and the documents that are up there, not for the adoption of the solution documents. So as mentioned before in the slides, there's, I don't know, 10 plus documents out there somewhere. So thinking about that, what that means is that there will probably, if there is interest, right, that's the first, of course, gating question, right? If there's interest from the community to work on any of this, there will probably need to be additional discussion on what any solution would look like beyond the framework, which is one of the reasons why we believe that if there is interest, and I keep saying this because that's the really important part, it wouldn't be appropriate for the routing working group to take that on, but it would be better to have a focused discussion somewhere else. So I think we should start there, right, and see if there's questions here. I see Yari standing in line somewhere. And if there is interest for us to continue the discussion on adoption, and if there is, then we can figure out what appropriate next steps would be and where we can constrain some of the discussions.
Thank you.
Thanks, Alvaro. Sounds great. So next step is for us to send email to working group. Oh, Yari, go ahead.
Yeah, sorry, I didn't want to jump the line. I was just waiting for opportunity. So did you want to finish or?
Oh, please go ahead.
Yes, I just wanted to say that in general, I'm actually quite interested in this application-aware networking area in general. Then I'd like to enable some collaboration between applications and networks. But unfortunately, on this particular topic or proposal, we've had some time pass by because, I guess from my perspective, we've been maybe a little bit too ambitious in terms of what we're trying to achieve, and that has caused some issues. If I remember the latest BOF conclusion, there was actually two major issues. Issue number one was that do we actually need new NCAPs and protocols to carry stuff, or are existing ones sufficient? So that was one issue. The other issue was that several members of the community felt that if you have two general mechanisms for carrying information in the package in this manner, then there's a danger that they'd be used for highly granular application or user identity or location identity or similar things, and that might be privacy-wise not great. So I'm interested in like what was the fate of these two issues, and I'm sorry I haven't actually checked the GitHub repo, but I will if you post a link there somewhere. The other comment that I had, that we separately have been writing, some of us, Tommy Pauly, Emilia, Ted, a document in the IAB about path signal collaboration, draft IAB path signals collaboration. I think it is 00. And that document tries to set out some guidelines on when like collaboration can happen and when it cannot, for various reasons, whether it's privacy related or whether it would somehow limit the evolution of the network in the future or would endanger some issue. So I'm not saying that our 00 draft has all the right ideas. It probably doesn't, but it would be a useful exercise to take that and run it against the current proposal that we have for APN and see whether all the suggestions are complied with or not, and that could lead to either changes in APN or changes in our document. And I'd be happy to work on that together with some other people if you're interested. It'd be nice to have a test case for that document as well. I don't have a comment on this, like adopting this framework. Sometimes I think some of these high-level questions are kind of very high level that need to be decided. The approach needs to be decided before you nail down the framework. But I'm not going to comment otherwise on that. Thank you.
Jari, the link to the repository has been posted in the chat, so you can use it.
I will post my link to our document also in a sec.
Joel?
I expect mostly this will come out on the list in the discussion, but the assumption that this framework is the right place to start on how do applications work with the network seems to be a false assumption, and the improvements from the addressing of the issues don't really change that. I would love to see us figure out a good way to get applications to interact with and request services from the network. No, that is a valid thing. That's something we need. It should take into account the privacy stuff that Jari and company are working on and lots of other things. But this framework is not the right starting point. It assumes that the problem is fundamentally a routing problem. And I don't at all think that is the place the problem should even be starting. There have been more BOFs than you can shake a stick at, which basically concluded, no, this didn't make sense to work on the way it is being approached. And so I think that the problem is more fundamental than just fixing this framework. Thank you. I will.
Thanks, Joe. So we'll take to the list. We'll send email to routing with CC APN, and we'll take it from there then. So the link to the repository posted, please review whether your comments have been answered, and we'll move to the next presenter. So Lynn, I can see you.
Yes.
Yep.
Can you hear?
Yep.
Yeah. Hello, everyone. This time we will update two old draft problem statement and the semantic address. Also, we have two new drafts. Today, I only give a little bit more discussing about third draft, instructive routing. Next slide, please. So here I just quickly go through our whole objective. Our objective is to explore open solution for layer 3 for large-scale LU constellation for internet access and NTN integration. NTN integration is a requirement from 3GPP for next-gen radio access. And the satellite network is huge, and the link is huge, and also the ISL is used, not like a current space link, Starlink. And it provides global coverage, and most importantly is following the regenerative mode in 3GPP. So most people ask me a question, which is the transparent mode. It only has a L1 work, so we are not working for that part. What we expect and what we do is that we just try to provide basic IP technology for satellite network, and we try to seek the feedback from working group. And obviously, this topic is pretty broad, and this presentation cannot cover all solutions. Maybe more draft will be coming. And we will not do anything regarding to 3GPP, related to 3GPP. Next slide, please. This is a review for the problem, and we only have a little update for the draft. And if you want to see more explanation, here we have another set of slides, more information there. And in the slides, I answered most of the questions collected in the previous meeting and also in the IETF E2 set mail discussing. And also I added the 3GPP NG RAN requirement for satellite network, where the IP infrastructure is required to provide the connectivity. So also in the slides, I have a simulation for mobility, links, and paths. You can see how dynamic of the network looks like. Next slide. Here is the update for the semantic address, and we only have add one section, 32-bit semantic address, and this picture shows what is the address will be look like. We have 3 indexes, and you can either use it with IPv6 or use it independently. Next slide, please. Now we come to the new draft satellite interactive routing. So the purpose is to provide a routing solution for satellite network. Why we need to do this? Because we have, if we use IGP or BGP, we have following challenges. Link keep flipping, and the link matrix keep changing. Then unsteady link also flipping. Also the possible link interruption at polar area. Above will cause huge IGP protocol message flooding if we use IGP. Of course, that's only one protocol right now in industry to do the adversary routing. So IGP, we're facing a lot of problem for this, and we'll dramatically reduce the service time. Next slide, please. This is a picture how the satellite network looks like. It has 2 sets of satellites moving to 2 different directions, and we have a terminal connect to satellites, connect to user. Also, we have a terminal ground station, gateway ground station connect to internet, also connect to satellites. All these links keep changing, and the link matrix also keep changing. And in addition to the mobility of satellites, the ground station also keep moving because of the Earth's rotation. So next slide, please. So if we use IGP for to provide IP connectivity, definitely we can do it. But the problem is that a huge number of links there, and the link is keep changing. So which will result in the service time dramatically reduced. Here we have formula. Some paper analyzed that said only less than 20% time will be service time. Other time will be in the convergence. Next slide. So when we consider the solution, we have to think about what is the spatial characteristics of the satellite network. First of all, satellite network, according to 3GPP, it's just a kind of carrier network or the transport network. So the only provided traffic, transport traffic between satellites or between the ground station and satellites. And the LEO constellation has well-ordered topology, even it's extremely dynamic. So first of all, it's a multi-layer grid network, even interleaved and moving to different directions. Second is that its link number is limited, about 4 to 6. And also the address, as we proposed in the semantic address, their address can be self-explained. So we can use that to identify each satellite. So the last is the satellite position is predictable because everything is following the physical laws, and if we know the orbital elements, we can predict the adjacency and also predict the link matrix, because the space environment has much less interference like in our atmosphere. Next slide. So here we have the principles for our hybrid solution. First, we want to maximize the usage of the computation and in the routing to reduce the messaging. So for example, we can compute the network topology, and the link matrix also predict which satellite can be connected to which ground station. Second principle is that we want to borrow the IGP for the satellite network topology and the state detection. So one proposal is related to the OSPF. We can use the OSPF to maintain the link state. Third one is that we can utilize the semantic address for the routing purpose. The last is that we want to minimize the routing overhead, because if we directly use the IPv6 or segment routing, and we will see a huge number of the overhead. So we want to reduce it. That's the purpose of the last draft. Next slide. So here I just quickly go through how the interactive routing works. It's very simple. It's kind of a source routing. Basically, we have the source to calculate the path like this, from terminal ground station to destination ground station. We are a couple of satellites. Then we can easily convert this to be a couple of segments. And the segments is either on the same orbit or on the adjacent orbit. And after compressed to be segments, we can convert to be instruction directly, because we have very limited number of the forwarding direction and also very limited number of the links. So for example, we define the instruction as the function and the arguments. We have a set of functions to guide the satellite forwarding to which direction. Actually, we only have 6 directions majorly. And then we check the arguments value to see if we reach the end point of the segments. So finally, we have very simple instruction list. We can embed it in the packet. Next slide.
Lin, 1 minute.
Sure. Next slide. So here we give the one user plan example, which is a tunnel-less. We just introduce a new routing type to embed the instruction to be packet. Next slide. Yeah, here is a summary of the interactive routing. I don't go through each of them, but compared with the current solution, definitely we can see the advantages, either in the lookup or the memory or the overhead size for the packet, also reduction for the ISL link bandwidth. That's all. Thank you. Any questions?
It'll just be a generic response.
You need to put yourself in the queue and then. Jens, take it to the mic. John, go ahead.
So this is pretty interesting. but I have kind of a basic question I don't think has been addressed, which is this a good candidate for standardization? I mean, to my knowledge, and this is not my field, these satellite constellations are proprietary networks that are launched and managed by a single entity. So I'm not going to argue about the value of the research. I'm just wondering, is this a thing that's a candidate for standardization? Thank you.
Yes, actually, for that question, I have some answer in my problem statement workshop. The why IETF need to do this. I have listed some reasons. Yeah.
Okay, thank you. I'll take a look.
So in general, you're asking for significant amount of work that is large and requires either new routing protocol, at least some changes to MANET potentially. What are your expectations? There's a significant number of drafts that are progressing kind of asynchronously. What do you expect?
We agree. This is a pretty broad topic. And right now, there's no dedicated working group in the IETF. At this moment, we just seek the comments from different groups to see what we can proceed.
Okay, thank you.
Yeah.
Let's continue with the next one. There was a question from Yingzhen. The draft is informational. Is it intentionally, or you plan to change the status eventually? Lynn, sorry, it's still to you.
Hello, can you hear me?
Yeah, just give me 1 minute. So if Lynn comes up, he can address it. I see people positively reacting and asking to continue this work in IETF. It's still unclear where and when, so we'll continue the discussion. Please go ahead, Yingzhen.
Okay. Hello, everyone. I'm Yisung Liu from China Mobile. And today I will present the considerations for the protection of SRR6 networks. Next slide, please. And first, we use the protection of SRR6 network by the SR6BE and the better for effort parts or the TE parts by using the policy. And if we use the TE parts, we recommend the compressed segment list encoding. And for the protection of the SRR6 network, firstly, is the parse protection, including the local protection and the E2E protection. And secondly, is the service protection, also including the local protection and E2E protection. And the third one is the coexistence of the service protection and the parse protection. And the third part, I will introduce the running code status in the China Mobile. And the fourth part, I will give a very quick overview for the examples. Next slide, please. For the parse protection, and the first is the local protection, and definitely we use TFA, and if if the compressed SRI6 is enabled in the network, we recommend the GSRI6. The repair node should try to use the compressed seed to encode the TFA repair parts. And to the E2E protection, and the candidate parts with the second highest preference can be selected as the backup parts. And if all the candidate parts fail, and we should use the BE parts. And for the liveness check, and for the local protection, we can use the BFD for the interface or for between the neighbors. For the policy or for the T parse, and we can use the BFD for the policy. Next slide, please. And for the service protection, it means that the egress PE deploy the same service like the VPN. If the primary egress PE fails, we can switch over to the backup PE. And for the local repair, we can use the SR6 egress protection draft and with the mirror seed. And for the E2E, we can use the ingress node switchover and steer the full flow to the parts of the backup egress PE. And the liveness check recommended use the BFD for the locator or the P address, or for the specifically use the service seed. And the coexistence of the service protection and the path protection, we have two strategies. And the first one is the egress node first, and the second one is the TE first. Next slide will show more clearly. Next slide, please. And for the strategy, and for the primary and next hop, we for the both of the strategy, we use the TE parse to the PE2 and the primary egress PE. And for the egress node first strategy, one the primary next hop fails, and we will switch over to the SR6BE parse to the PE2. And but for the T first strategy, we will switch over to the TE parse to the P3 and move to a backup egress PE. So that's the main difference of the two strategies. It can meet the different requirements of the operator. So next slide, please. Okay, this is the running code status in China Mobile. We have finished the lab interop test last year by using the GSI6 for the above protection solution. By using the controller from the China Unitex and by the device from the Huawei H3C and ZTE. And also we have finished the trials of the GFS6 protection with the above solution in 3 province branch networks last year. Next slide, please. The next several slides, I will give a very quick overview for the examples. Next slide, please. Firstly, it's the SRE6BE deployments, and for this example, we deploy the BE parts to the PE3 and the PE4, and the primary PE and the backup PE, and we also deploy the BFD for the locator of both of the egress PEs, and all the nodes enable the TRFA. Next slide, please. If the BE parse failure, just use the TRFA repair parts to protect the traffic. Next slide, please. And if the egress PE failed, the PE1 will check the switch over to the SRE6BE parts to the backup PE, the PE4. Next slide, please. For the SRE6 TE deployments, it is more complicated. And for the to the primary egress PE, we deployed one policy with the primary candidate paths and the backup candidate paths. With both of the paths are the strict TE paths, and we recommended use the BFD with the forward paths and the reverse paths have the same paths in the back direction. And we also deploy the BE paths to the P3 for the primary egress PE. And for the backup PE, we deploy the loose TE paths and also the BE paths. Next slide, please. For the policy to the egress P, primary egress PE, when the strict path failure, the P1 will check the switch over to the backup paths in the same policy. Next slide, please. If both of the paths fails, and the P1 will check the switch over of the first priority backup. That means the SR6B paths to the P3 because we use the egress node first strategy here. If we use the TE first strategy, it will switch over to the P4 policy. Yeah. Next slide, please. And if the primary egress P, the P3 fails, and the P1 will switch over to the SR6TE loose paths to the P4. Next slide, please.
1 minute.
And okay, I'll be quick. For the loose path failure, if the failure happened to the non-endpoint node, we can use the TRFA repair path. Next slide, please. If we happen to the endpoint node, we can use the switch over to the BE path, and that's all. Next slide, please. Any questions and comments?
Yeah, we've got people lining up. Jeffrey? Jeff, we cannot hear you.
Sorry, I'm fighting with the echo. Jeffrey Haas, how are you provisioning your BFD return path?
We have provide other draft for the parse consistency for the SBFD in the BFD working group that we have the details.
Is this the BFD directed draft?
Yeah.
Okay, that was the answer. Thank you.
Okay.
Tarek?
From Juniper. I can't remember the slide where you showed the primary path and the backup path to a different egress P. I think it was slide 14, but I might be mistaken. So my question is maybe, okay, I'll assume PE4 is the, not sure here, which is the primary and which is the backup. My question is, what happens if the CEPE link on the primary egress fails? That BFD is, my understanding is the session is towards the PE node, egress PE node, and the egress PE node is still alive. So you won't be able to fall back to the backup candidate path. The BFD session wouldn't tell you the fault in that case. And In that sense, why is this protection not done at the service level, at the BGP level? Thank you.
Okay, thank you.
Are you going to answer it, or you prefer to send it to the list? I believe Tarek asked a number of questions. Tarek, would you send your questions to the list, please? Tarek?
I will send my questions to the list.
Thank you so much. Chengli?
Hello?
Yeah, we can hear you.
Okay, perfect. So no questions, only comment. I think it is a really impressive presentation. I'm really happy to hear an operator can share their real issues and considerations from the test and deployment, right? It definitely can and help us on how to develop the network in the future and guide us to drive the work into the right direction. So really, thank you. Yep.
Thanks. Jeffrey?
Yeah, Jeffrey from Juniper. I might have missed it, but what's specific about SRv6 here? Or what cannot be done with SR and POS? What's different?
I don't think we are going to get an answer. Could you please send it to the list? I don't see any reactions here.
Thanks.
Okay, then we are moving to the next speaker. So it's going to be Bargafni instead of Rtgwg. And just to say a few words, we have discussions with transport area people on this draft. It touches upon routing actually quite a lot. And as many other presentations you've seen, we are looking to ways where hosts can interact with the network. So it's one of those. Barak, please go ahead.
Thank you, Jeff. Can you hear me?
Yep.
Excellent. So yeah, I'm going to present HPCC++ here. And this is an enhanced high-precision congestion control suite. Work together with Rui and the team here presented on this draft. Okay, so let's reiterate what are we trying to address here. So we started with a focus on looking at cloud providers' environments. And there are a couple of things that happened in the recent years that drove our interest. Starting with the high-performance storage, and the change in the storage environment recently drove a much higher throughput and lower latency access to the storage. And we see order of magnitude of million IOPS and about 50 to 100 microsecond response time. And this is kind of order of magnitude less than what it used to be before SSDs and NVMe were introduced to the networks. Another angle is a high performance computation, or HPC. With the rise of distributed deep learning, with the move to having a more kind of heavy loaded applications on the network, the use of GPUs that drove much more bandwidth and traffic towards the network, FPGAs and ASICs. All these shifts put a lot of pressure in the network because the compute become much more capable and much more demanding in terms of the communication patterns in between these devices, as well as lower latency because the computation is distributed, there is a lot of dependencies between the various nodes. And this drove the latency even further down towards sub 10 microsecond requirement. and even below that. In addition to that, resource or memory disaggregation in the network, so the servers, kind of architectural changes on how we built the servers or the compute elements. Basically, because we disaggregate, all these components used to be in the same box or chassis, if you will. Now, when we disaggregate them, we present latency from the network. In order to overcome it, we need to give services that are even lower latencies than what we already discussed. So all of these kind of drove us towards looking into solutions to enable higher bandwidths, consistent bandwidths, and lower latency as well as consistent latency.
Greg?
Yes.
Greg Mirsky?
Couple questions. So first, there have been comments to the draft before the meeting, and I just wonder if authors noticed them.
Yes, I think we will address it probably at the end of this deck.
Okay. Another question is that's something that I think that I didn't ask in my comments.
Is it related to what, Greg, is it related to what was already presented now, or is it more general?
More general. Okay, I'll wait then. Thank you.
Okay. Thank you. Great. Okay, next slide, please. All right, so if we kind of take a deeper look, these were the applications, but now when we look on how the network is actually, or the host side is actually serving these applications, then what we see is that hyperspeed networks chips actually form hyperspeed networking. What does it mean? We talked about the application again, but now not only that the application has been changed, but also the host or the NIC, if you will, has been changed. And we see more and more demand and installations of hardware offloading in the NIC. So if you look kind of on the history in the past, and especially considering TCP and the like, what we have seen is some offloading, mostly related to things has to do with hashing and so on. A little bit handling, the messages and cut them into packets and so on. But a fundamental change happened with hardware offloading that has to do with RDMA or remote direct memory access. That means that a lot of the transport actually is being offloaded into hardware. So no need to go into CPU and software anymore in order to handle networking. And this caused kind of order of magnitude jump in latency and bandwidth in the network. In order to be able to keep up with these demands, this is why we were looking into real-time congestion control, because there is a lot of data and communication running in the network, meaning more pressure on the network. And it becomes harder and harder for the network to be able to serve these requirements coming from the servers. Next slide, please. So what are the challenges that related to congestion control in high-speed networks that we discussed? Convergence upon congestion. So if congestion happens in the network, then how fast would the network be able to solve this congestion and basically reduce the load in order to be able to prevent the congestion? And also, how fast will it be able to pick up once congestion resolved? So these two challenges we try to address. Running multiple applications over converged networks. So as you're well aware, these cloud environments that we began with and later on thought about other use cases, they may run multiple applications, and the requirement is to be able to not have dependency between them. And this is why costs and buffering are scarce resources in the network, as you're well aware. In addition, because current congestion control algorithms, whether using ECN or not, has a lot to do with many parameter tuning. It has to do with the fact that the visibility into the network is limited. And then some kind of heuristics has to be made. Next slide, please. Here I will kind of present, should I say, an opportunity that has to do with the evolving telemetry capabilities in the network. So when we're looking into in-band telemetry, and when I say in-band telemetry, and maybe this is at least partly address some of Greg's questions, we refer to that as the capability of embedding telemetry on an in-flight packet as it drives through the network. What we see in recent years is that new networking ASICs that are coming to the market have these type of capabilities, and they are already deployed in today's cloud networks. As I mentioned, packets can collect telemetry on their route. And in terms of standardizing these capabilities, we see efforts in a couple of places. One of them that might be most relevant here in this forum is the IETF IOAM specification, which is being worked on as part of IPPM, which standardizes basically the data structures to enable these capabilities. There is a work under p4.org that's called INT, and there is a draft suggestion under the name of IFA that was suggested for IPPM, but is not progressing as a working group draft at this stage.
1 minute.
Next slide, please. So can we use this new tool as a precise feedback for congestion control? Potentially, yes, and this is what we were looking at. Based on very precise visibility into the network, sender and host in general can adjust the rate. Potentially, they can adjust also the way the route that the packet may take in the network based on this feedback. Next slide, please. So there are a couple of formats, as I mentioned. Because of time, I won't get into too many details. But we are not asking to discuss the format of the packets here, just the requirements from the in-band telemetry specifications to be able to support data that is needed from the network for this purpose. Next slide, please. So we address all the challenges that we discussed. Fast convergence, so we have good visibility for the senders. Near zero queues, we do not need to rely on queue build-up anymore. And way less parameters to configure because of, again, this precise feedback that we get from the network. And we can take better decisions from congestion and routing perspectives. Next slide, please. So how do we see what HPC++ is? And this is related to Jeff's comment at the very beginning. The way we see it is this is basically a service. It comes to serve the networking entities, whether it is transport or routing engine. But based on this data that is being built in the endpoints, we can take better decisions and serve the applications better. And this is why, when we came to discuss also with some of the transport teams, because it is transport agnostic, basically, then there is no specific transport that it ties to. And it is also routing protocol agnostic. It's basically a service that can be used by different entities in the network. Next slide, please. And we will be more than glad to get the working group feedback on the details and on how to proceed. Thank you.
So as I said, there's an ongoing discussion with transport area ADs, and we'll keep you updated what's going on here. And we've got David Black.
Oh, Lars, he has more dots.
Excuse me?
Please let Lars go before me.
Hi, Lars Eggert. Speaking as an individual with no dots. So I think this is certainly interesting for transport, and I think the congestion control part of this would certainly need to be standardized there, and there are like ways in which we do that. I'm sort of, the interesting question for me in routing is whether switchers and routers would be willing to provide this information. And it's good to see that there's already some vendors that do so, and I think the problem for this sort of network-based congestion control was always that we couldn't get the information, we, the transport, couldn't get the information from switch fabric. Like ECN, for example, right, never really took off because we just didn't get the bits. So if this has not changed and there's the possibility to get this information from the network, that would be great because it opens up all kinds of things like HPCC and others. And I think for routing, the discussion would be, is this something that has changed on the routing side where the network would be willing to offer this?
Thank you, and that's exactly it. We are finally getting to the point in time where networking equipment can actually communicate back what it does. So, and again, the question where it should live really stays open and ongoing, but this work is kind of really important. The amount of RDMA traffic in large data centers is going up exponentially. They absolutely need to keep routing simple, so using today's BGP, SSIS, shared path routing, they need better congestion control to be able to change entropy, to reduce transmit rate. And this is really work that's going in this direction when host can interact with the network and do something useful with it. Dean, please be clear.
Dejan Bogdanovic. So I have a concern that with the speeds that we are approaching and the latency that is, that we are seeing, we are hitting that the information by the time it arrives, being computed and being propagated back to the source might be already old. So we have to, if this really wants to work, I think we should consider that we have to put in a poll mechanism, because today we do all the routing on the push mechanism, that we should also do a routing based on the pulling mechanism in order to try to avoid the congestion, to find a solution for a congestion control.
Very good comment. And please do send your comments to the list. And I believe authors would be more than happy to address them. And we have to move to the next presentation.
Thank you.
Thanks, Barak.
Good. Trying to use the new tool. Still getting a bit used to. This is a draft that comes out of research we've done on DLTs and provider networks. We try to better understand what DLTs as a technology is doing to networks, and we thought sharing the insights here with the routing working group may be quite useful because we are seeking input as well. I'm trying to see how. Okay, now it finally comes. Sorry, it took a bit. So the war games to understand how, what's the impact of DLTs if you run DLTs. It doesn't question why we're using DLTs. We're taking any DLT application there is. But what happens to a network when you have DLTs running on top? And the footnote here is quite important. We started our insights. They were all experimental. We started them based on proof of work-based DLTs, Ethereum at the beginning. And that's one of the pieces that we're looking at other DLTs as well. We want to engage, and we took this work first, and we took it actually into the IIC. There's an IIC white paper on the Industrial IoT Consortium. You can read the white paper. Link is in the draft, and we wanted to turn this into a living document. We want to get more insights, in particular from folks who understand routing quite well. So we want to engage with the community, and both want to extend on the impacts as well as on the opportunities to maybe mitigate some of the impacts. So we have a structure you can see here where we talk about DLT concepts, so that's a little bit to understand how DLTs work. I'm not going to go into this. A bit about the communication in a DLT, so what does a DLT really do in terms of communication to your network? Some of the challenges we're seeing, as well as the experimental insights that we currently have, as well as some of the opportunities for network innovations that we also see moving along that may help us there. So what's a typical communication in a DLT for those of you who are maybe not that familiar what a DLT really does? The DLT is a form for a distributed consensus system. You have a client that commits a transaction request to the DLT. A miner or a peer, generally, we call them peer largely in the draft, more commonly known are miners, for instance, for proof of work DLTs, commit a found block to the DLT as a piece of the system, of the ledger, and any client or another miner may read the blockchain from the DLT. That's kind of like the typical communication pattern or the interactions you see in a DLT. In all of this, it's important that these operations are inherently multi-point. And the nature of that multi-point is something we, in particular, investigated with quite some interest, because that's one of the biggest issues in the DLT we've seen. The communication pen, so how do you translate this? The key aspect that's being used in the DLTs is the so-called pool of peers to talk to. So the peers you're communicating the request, the DLT information to. And this is a very, very simple flowchart. I see there's something gone wrong in the flowchart in one of the return paths. Apologies for that. You find another picture in the draft. So it works off a list of DLT peers, which is being distributed through the network. These DLT peers are usually described as IP addresses, ports, and with the ports, the protocols you're maintaining. It does node discovery, so it builds a list of peers that it understands it could communicate with. And then it picks randomly from those peers a number of nodes to communicate with. Transport security is trying to establish a capability exchange that's pertaining to particular protocol aspects, security aspects that you may need to support, but also hardware capabilities. Do you have a GPU, for instance, if you do a proof of work DLTs? On the left-hand side, you see the incoming peers. You may also be contacted by an incoming peer who does the same thing on their side. So there's a lot of chatty communication happening. And in the end, a successful peer is being added to the so-called pool of DLT peers. By configuration, to give you an idea, in Ethereum, these are by default 50 peers you're communicating with. These 50 peers keep changing over time. So if you think 50 is a relatively small number, when we run the numbers and trying to understand how much in a certain amount of time you're actually talking to, you end up at thousands. Because the pool of DLT peers keeps being randomized over time. And they all go through this mechanism of node discovery. You do a type of TLS, type of transport security, capability exchange, and up to the pool, you're being evacuated from the pool after some time, et cetera, et cetera, et cetera. And that's kind of one of the biggest things that's happening in the DLT peers. Now my button's disappeared. Okay, there you are.
While you're doing, there's a question whether the pool is bounded.
It's configuration. It's all configuration. 50 it is in the beginning by default configuration. You can set this larger, but we run it in the default configuration for Ethereum. Thanks. So the problem is the one thing is you require information to reach other peers. In DLTs like Ethereum, you have bootstrap nodes. So you sign up to the DLT, you give up your IP address, the bootstrap node seed the actual node discovery. It maintains the IP addresses of all the miners plus the port information. So you're also indicating whether you have support for UDP, TCP. The new DLT members, as you saw on the previous slide, they need to discover and maintain these addresses all the time upon joining, and they are being refreshed, as I mentioned, several thousands. Also, clients don't know anything about the capabilities. So I go through this whole thing about I contact a potential miner, I have an IP address, I go to the IP address, I wait for the connection, and you notice the waiting for the connection is very bad if the IP address isn't actually reachable because you have a timeout, so you're just waiting 30 seconds for nothing. You inquire the capabilities, and you disconnect if they are not matching. And again, if you run this actually in an experimental setup, you'll notice there are a lot of disconnects just simply because folks are not meant to talk to each other. Right? A lot of these thousands of connections are actually unsuccessful connections. So miners may never reply. Finally, if you have the pool, then obviously you end up mapping the sending of transactions onto unicast communication, right? So that negatively impacts efficiency because you do unicast replications like in many overlays. And it also impacts the completion time because you have to keep doing this as a replication rather than a multicast. The last problem that we outlined is that you need to expose the IP address. Well, that's never a very, very good idea. In particular, if you look at the idea behind the DLT, and that is communication between possibly inherently untrusted parties, well, hang on a second, why am I giving my IP address to these people? Right? I mean, I'm not trusting them even on the ledger information, but I'm trusting them with my IP information. So you set an IP address, it leads to privacy issues, security issues. It's difficult to handle IP address changes because they have to propagate from the bootstraps into the miners. If you change your IP address, you may still have, and this is also happening quite a bit in the discovery process, you're actually contacting IP addresses that are already outdated. And you notice this by waiting 30 seconds. Right, nothing is happening. Supporting mobility is another issue, obviously. Sorry, there was a slight lag in this one. The experimental insights, they are at the moment taken from the ISC white paper. We're also already working on newer ones that we will put in another update. They're constantly coming in because we're running the experiments as the days go by. There are different types of DLTs. As you can imagine from the pool before, from the chart, there's a fairly large number that are just simply not reachable. The IP address is in the bootstrap nodes. Good luck, you try to reach them, the ping never comes back. They may just signal, we call them just signaling, because you're going through the capability exchange and nothing is really happening. You have mismatching capabilities. But you also may end up in the end talking to an actual node after capability exchange, but they're sending you useless data. Useless data, the data you start with at the very beginning is the blockchain. You want to synchronize on the latest blockchain, but you may never end up with actually getting any useful data from them. Last but not least, you actually have miners you finally talk to usefully. So that's the last type we identified. And only 16% of the nodes are actually useful. The rest is rubbish. And depending on what stage you fail, it is big rubbish, small rubbish, it depends, right? 42% of the traffic is wasted. We found this out so far, and we're refining the data at the moment to split where the waste actually does happen. I said we have the additional KPIs that we will put into an update after 113. So what are network innovations? We're outlining this in section 7 and section 8, and we're just starting there, and we're also reaching out in some of the research space, and Adrian is going to talk about one of these things, 2 presentations after this one. So references to ongoing drafts we have there. There's opportunities that we're looking into in multicast. There's a whole discussion around why is it you can't really quite use multicast. If you look at the random nature of these pools, you might guess why that's the reason. It's extremely dynamic multicast. We also link into standardization efforts in the IEEE, DLT work, that's DLT interop work that's been done in a couple of site meetings, the semantic routing that Adrian's going to talk about later, DNRG, and we want more input there. So what are we having going to the last, no, it's not quite the last, on the last slide you see a site meeting that's happening tomorrow where we actually do talk a bit more about this. So what's next? We want to extend our work more to understand more about other DLTs as well. We already received input from folks and said, hang on a second, there are other DLTs, I know, apart from Ethereum, we know that, but we would like to get insight from people who do work with them. Other proof of work systems, proof of stake, which works significantly different in the impact on the overlay management. Insights into Ethereum as well. We're doing this already, as I said, as we speak. Other network innovations, the use of IP multicast list, that's something Dino works on, that we're going to talk also about tomorrow. And the impact of those network innovations. If you assume those network innovations, what would be the impact? How would you mitigate the impact we observed over traditional IP? And that's something we also work on. Most importantly, we're looking for collaborators. So this is meant to be a living draft. So hopefully we get other people to join.
You're eating into your next presentation already significantly.
Yes. So we need the why. So one of the reasons to doing this, as I mentioned, oops, stay over there, is to better understand the impact of DLTs. So folks who have had insights into DLTs, please contact us. We're very interested to incorporate that in any updates. Any possible mitigation, if you worked on network innovations where you mitigated some of the impacts we observed, very good. Any contributors, please drop us an email. There's a bit of advertisement there for a site meeting tomorrow. That's going to happen on DLT and networking. It will have the spins of impact of DLTs on networks and the other way around. We're going to talk, Dino's going to talk about Lisp and what they've done. We're going to talk about a bit more detail of what I described today, already some of the newer insights. So if that fits for anybody, 6 p.m. local time, please join. That's just a site meeting, by the way. It's not going to be buffish oriented or whatever. That's just people coming together and talking about this topic. So if you're interested, then please join us.
There's a question from Nicola Rossignoli. Nicola, go ahead.
Hi, this is Nicola. One question. Have you looked at the security implication? I'm thinking, for example, about routing security. I think there was some research on using, for example, hijackings for stealing Bitcoin. Or I'm also thinking about DOS, for example, for leader-based, BFTs. Is it something that you have been looking at, or just not yet? Or
So our current focus has been largely on quantitative performance, but the security part in recent discussions, it's not in the draft at the moment, but certainly something, if you could send me, for instance, the research, that would be great. And as I mentioned, if I'm not trusting the DLT, but I'm throwing my IP address out. So it's quite clear that there are a lot of interesting privacy and security implications, on that. And I'd really like to hear more about that.
all right, I'll see you at the site meeting then.
Yeah, thank you. Thanks.
And next presentation, yours as well.
Do I need to request that again?
Engine, you loading slides? Yeah, it's coming up.
Good, thanks.
You've got 5 minutes.
So gotcha.
Or we can move it for you if you want.
That one didn't show up before. I'm still getting used to the remote tool. It's a bit buggy in places. So this is a draft, goes away from DLTs, but even though we're also seeking, obviously, input by the wider community. This draft talks about, is purely observational. We look at how the internet has evolved from what we usually, in particular, very often simplistically teach people on what the internet is really doing, and that's reachability. And it's titled, Continuing the Internet to Evolve the Internet Routing Beyond Mere Reachability. It's intended to seed discussions on how we can continue with the observed evolution of the internet routing system. And as I said, the draft is positioned as being purely observational. We're not proposing any solutions. We're just saying that's what's going on. How do we want to continue doing this? We want to engage with the community to identify on possible next steps so that this routing evolution that we've been observing for the many, many years actually continues. Structure of the draft there as well. So I'm going through 2, 3, and 4 section in these slides. But there's also obviously more discussion on the issues which I ask you to look through the slides in more detail. So we start with the original purpose. So this is kind of like what we usually tell people of how the internet works. All right. So originally it's designed to enable forwarding IP packets to a destination address. That's good. We have a locator semantic for IP addresses. That's fundamental for doing this. Usually assigned in context of network topology so that we can get some sort of management of this address space. We have distributed decision making and intermediary routers, which sometimes also leads to issues and routing problems in particular, which some of the extensions are particularly addressing. Key when looking at this is what's the method for selecting the path, and what's the criteria for doing so, right? Traffic engineering may help you to avoid some of the routing problems. So this is how the routing system really started, but there are many, many extensions to this reachability part, and as I said, the draft has gone through an exercise of listing those and going through, in the end, 58 references that we found so far, and we by no means claim to be exhaustive, but we just wanted to start somewhere. There's a 00. So we observe and survey those extensions, and we list them based on what's the purpose for the extension, what's the approach, what's the underlying technical approach, and you can just, we can debate some of those taglines that we used. And what are the examples? What are the known solutions? So we want to have the evidence part, right? And ultimately, we hope that this may lead to some sort of taxonomy that looks at the capabilities of a routing system and the approaches for achieving those routing systems. That's kind of like what we are after with this section. At the moment, and this is on the right-hand side, it's just a snippet, obviously, of the entire table, because the table has 12 purposes, which is the leftmost column, 26 approaches and 58 examples. And as I said, not claiming to be exhaustive here. So the key observation, though, that we're doing with that is that the internet routing has been evolving. So whatever we are saying about internet routing, maybe all it does is reachability, not really quite. There's been a lot of stuff going on, obviously, that has been tweaking and changing things here and there in order to do certain purposes as we defined it using certain approaches. That's the observational part that we have in this draft. But if you do those, we also discuss in section 4, what are the possible issues when you take these approaches and start playing around with the routing system in order to achieve the purpose that you have in mind, right, that goes beyond pure reachability. And we outlined a number of them that are discussed in more detail in the draft: limiting routing capability, semantics, so you fit the new purposes into the limitations of the old realizations. There are a couple of examples that are given there. For instance, on content naming, great idea to extend the purpose of the routing, but unfortunately, if you stick it into the limitations of an IP address, you're limiting the actual new purpose itself, right? That's one of the examples we give. Complexity and efficiency, because...
1 minute.
Yes, you have repetitive encapsulation, you have security, fragility, interoperability, a number of issues that are being listed. So what we asked the routing working group in the draft at section 5 is to recognize that the evolution of the internet routing system has to take a wider architectural approach and not just start sticking extension here and there and knock yourself out with the packet, whatever you want to do. There's a lot of research and development on routing systems ongoing, research being published, developments in companies, and these works must be brought into the process of the IETF, and we believe it must be brought to the IETF before we start sticking it into a new specification, because that's relatively late. And we believe, looking at the routing working group charter, that the routing working group should play a role in all of this, because as it says, and we are quoting the charter there, the routing area working group is chartered to provide a venue to discuss, and that's kind of like what we're looking for, to discuss, evaluate, and support new proposals. So we are establishing three actions in the draft that we are suggesting: either to establish suitable efforts within the routing working group, or to support the establishment of suitable efforts as a standalone working group, which could be, for instance, called the Future of Internet Routing. That's just a suggestion. Or support the establishment of suitable efforts within the IRTF, where these efforts directly liaise back with the routing working group through regular updates in its meetings. So what's going on at the moment there, right? So these are the suggestions we are making in the draft. And what we ask for is comments both on the recognition and the suggested actions, either here on the list. We also have the manifesto that are linked in here, which Luigi published last year with other co-authors. And important, what we want to say is we are not asking to risk, this is something that we in an exchange was put to us, we're not asking to risk the investment of the internet just to make architecture a process. On the contrary, we want to ensure that we have a continued evolution without the issues that we observe in the actual draft. So we're not asking to throw this all away and open the discussion for the pure research purpose, but actually really ensure that we can continue doing routing evolution sustainably.
I would really need to stop now.
Thank you.
Thank you. While Adrian is loading under your draft, a couple of comments. So there's no concept of subgroup within group in IETF. IRTF, probably to your knowledge, had a research group focused on evolution of internet. So bringing it to IRTF, if you are doing research, probably the right thing to do. Obviously, you can also ask for working group in IETF, but this far, I don't think there's enough meat on the bones to really do this. So if there's significant interest, we can definitely have an interim meeting focused on what you're trying to do. So please send an email to the list and see whether you can gather enough interest to continue this work. Here, practically, it feels like IRTF probably would be the good place to continue this effort.
Okay, thank you.
Thank you.
Thanks.
Adrian?
Yeah, so I'm requested slide, and...
Injing?
Slide share requested, but nothing happening.
Robin, could you please send your question to the list? Sorry, we are really running out of time.
There
Okay.
we are. Oh, cunning, they're not in order. Right. Okay, I will squeeze us into the last 11 minutes, no problem, and spend most of the time reading the long title on this slide. So this is about things that we think that researchers should look at when they're doing work and proposing new approaches for internet routing. And we've come up with some challenges which are in the draft noted at the bottom of this slide. The main things we're looking at are things that are not always looked at properly when new routing proposals are made. Things like stability and scalability, security, privacy, manageability in particular, and interactions with other parts of the network. So that work breaks down into examining the fragilities in the current system, in particular, what breakages do we often see, and the architectural considerations, whether this is evolution or revolution, and then questions that we think that research and development should be spending more time on, working out what the deployment architecture is, what assumptions of traffic patterns are influencing the way the design is done. What is the techno-economic motivation? In other words, why are you actually doing this work? Is it just because it's fun, or is there some driving force? And then beyond that, the research principles that are quite often neglected are looking at realistic networks and realistic traffic flows rather than the sort of PowerPoint linear network that we often see used to prove new approaches, and the ability to independently reproduce the research. So none of this is attempting to criticize, we're just trying to be a little bit more helpful. So where this all started was us looking at semantic routing, and we've heard a couple of presentations today talk about semantic routing and semantic addressing. And this, from our perspective, is layer 3 hop by hop routing and forwarding. So not overlays, not traffic engineering. It's extending the historic routing algorithms that have been used to generate forwarding instructions, where we've had distributed but identical algorithms or central planning, and based on information known about or gathered from the network. So originally that was all just reachability, destination address. And as Dirk has just said, we're moving beyond that. Semantic routing then is looking at additional information that is placed in the packet somehow, whether that's in additional fields or overloading existing fields or partitioning the address space. And it's describing the treatment that the packet should receive within the network. So the routing decides what the next hop is for each piece of information, and the forwarding acts on those instructions, looking at the information in packets. So to some extent, all routing and forwarding so far has been semantic routing and forwarding, but we're looking at extending that. So you can get a sort of bigger overview or an introduction in the draft listed there. Very, very quickly, this figure just shows that architecturally, it looks like it's no big deal. We're sort of adding the red words semantic into an architecture. But I think this is an overly simplistic representation. And what needs to happen is a better look at the architectural implications and the consequences for the routing system, and maybe a step back and say, what are we trying to build and why, and how does this all fit together? So as background, as we worked on semantic routing, we did a survey and we found that there were an extraordinarily large number of pieces of work that were in this space, and many of them had petered out, some of them had failed, some of them had limited niche applicability. And we started to think about the common themes in researching and testing and developing these ideas, and the overlaps between other systems, in particular SDN, and their applicabilities in particular environments. And this led us to formulate our challenges and research questions. So why talk to you even about this? Well, we think the challenges apply more widely to all routing research, although we started with semantic routing. We're not trying to tell this working group what you already know, and it's probable that there are one or two people here who have some experience in routing. What we want to do is firm up this work with opinions from the real world. So what have we identified that's not really a problem? What have we missed? And what have we left out? So I have 3 slides here which are sort of extracted from the draft, and I'm going to skip them because you can read the draft and we're running out of time. They basically categorize the challenges and the things that people should think about as they propose new ideas, as they do new routing work. As you'll see, the last one there, does anything need to be standardized? And that comes back to the discussion in the satellite work that was raised before. So what are we going to do with this work? As authors, we're not completely sure. We don't know where to discuss it. We do have a place for discussing semantic routing. That's on a JISC mailing list. And maybe the chairs here would be happy for us to talk about it a bit more in Rtgwg. We do want to develop the draft, and we're not sure whether to turn it into a general document or restrict it to the semantic routing work. Obviously, we're going to polish and extend and take feedback from you guys. And that sort of takes me to this slide, which is what we're doing useful or a waste of time? Are there things we have that are wrong? What else should we include? And where should we discuss it? There you go, chairs. You have 2.5 minutes.
Let's take a couple of questions and I'll try to comment. Peng? Okay, so we've got 2 minutes and 4 people. Please be quick.
Okay. Some discussion in Rtgwg about it. So could you please brief us the process here?
What I can say is we talked to the IETF chair, and he said, try talking about this in the Rtgwg. We did, and the Rtgwg chairs told us that routing is not really in scope for Rtgwg. So we're happy to have a home, but we don't have one at the moment.
Robin.
Okay, thank you.
Okay. In fact, my question is that what means the internet routing? So I mean that you mean this today talk about the dynamic routing, but if it's used for the truly the internet, so I think maybe that's the research work take a long time. But it's used for the limited domain such as the satellite network, that's maybe engineering work. And my suggestion is better to distinguish the different scenario for this internet routing issue or semantic address routing. That will be helpful to distinguish where to have this work.
Yeah, okay, that's useful. Thank you.
Okay, Jeffrey.
Jeff, Adrian, 2 quick comments. Comment 1, I think this is useful work and I would like to see it carried forward regardless of what group it ends up in. Comment number 2 is that you have a very good list and I'd like to suggest that you add to it incremental maintenance of the mechanism. That's the thing that we usually end up tripping over.
Nice, nice. Thank you. Yes.
That's it. Thank you.
Tarek.
Tarek Saad with Juniper. Thanks, Adrian, for the great presentation. Haven't read the draft, I admit. I'll promise to read it. It's not a question, it's a comment. I see resemblance in semantic routing, what you're proposing on semantic routing, and some work we, myself and the co-authors are driving in T's working group, where we carry something in the packet that influences the packet forwarding or the routing decision on hops along the path. I think this work is useful. Just wanted to make that comment. Thanks.
Yeah, thank you, Tarek. And I should add that to the survey. And you'll notice that APN talked about earlier also influences the path. And I think that a question that needs to be looked at more generally is whether there should be an attempt to do a generic approach rather than picking environment specific or use case specific approaches and ways of doing this. Maybe we can come away with some generic encoding that's a little more capable of being used in many different scenarios. I think that might help the implementers if we can do it in a way that isn't too costly.
Colin, and we cut the queue. Guan Cheng, please take it to the list. Colin, go ahead.
Hi, can you hear me?
Yeah.
Yes. Okay. Thank you. So I just wanted to follow up on the comments about Rtgwg and about how this has been handled in the IETF. I think that the feedback I gave to Adrian previously was not to take the work to Rtgwg. It was that parts of the work overlap with the scope of Rtgwg. And I agree that Rtgwg is not a routing group. But what Rtgwg is looking at is how the network is becoming more programmable and some of the implications of in-network computation and programmable data planes and so on. And that, I think, overlaps with some of the discussions in the TS group, some of the discussions about, as Adrian said earlier, about what happens when the routing has chosen a path and how does the data plane handle the forwarding of that path. So I do think there is at least some overlap with the scope of Rtgwg, although that's clearly not everything here. I would probably argue that parts of this work also overlap with the ICNRG, and perhaps some of the topics that were mentioned in the previous talk also overlap in that space, because that group's considering what happens when the routing identifies content and the forwarding identifies content rather than IP addresses. But yes, I certainly agree that most of this does not seem in scope for the IETF. It seems much closer to engineering, although the feedback I've given in the past is that parts of it fall within the scope of some of the IETF groups.
Adrian, would you want to respond or just take for information?
I have nothing to add to that.
So the work seems to be really interesting, and it's common theme for half presentations here. So something is going on, and personally, I would really like to make something of this work, whether we call it semantic routing or policy-based routing on steroids, right? The willingness to extend route lookups beyond destination IP address is definitely present. So we'll discuss with our ID. Potentially, we could have interim meeting focused on the team, and we'll come back. Please do stay active on the list and solicit feedback and try to progress it.
Lovely, thank you.
Thank you so much, and thanks everyone, and hope to see you in Philadelphia, and hope to see many more people in the room. Thanks.